Hello guys, welcome back to Java session. In this video, today we are going to cover what is this thread, what is this thread model, and followed by how many ways we can create an thread, what are the lifecycle methods of the thread, and then we will see the example programs for different ways of creating thread, right? Now, sir, what is this thread? Before getting into this thread, sir, why we introduced this thread means, beta, if you want to perform more than one task simultaneously, that we cannot do without this thread. That's what we are introducing this thread. So that is a major drawback. To overcome the drawback, we are introducing this thread concept. Sir, what is the thread? But a thread is nothing but any lightweight process, a very lightweight process that can be called as a thread or a smallest part of the process, which allows the program to operate more efficiently by running multiple tasks simultaneously, right? So that is called as a thread. Now, sir, can you give a diagrammatical representation? But here you can see operating system, right? It is operating multiple processes simultaneously. Here, process one, process two, process three. In each process, you have a lightweight program that is called as a thread, right? So that lightweight thread, if you are executing one thread at a time, that is called as single threading. Sir, if I'm executing multiple threads simultaneously, then that is called as a multi-threading, right? Now, sir, what is the thread life cycle? But in thread life cycle, we have various states. Different states are involved. These are all the following states which are involved in the thread life cycle. That is new thread, ready thread, new state, ready state, that is also called as runnable state, and running state, then terminated state, and non-runnable, which is also called as blocked state, right? First, we will understand, sir, how to go through this thread life cycle means. But whenever you are created a thread, the thread will be available in the new state, right? Let's say, sir, I am created a T1 thread. So here I created a thread means the thread will be available in the new state. To start that thread, we use start method. So like T1 dot start, then the thread will start and it moves to the ready state or runnable state. If a thread is in the ready state or runnable state, that means it is ready for execution with all the required resources, like whatever the input which is required from the user, it is taken that input, and the resources which are required, it is requested the resources, and it is ready for the execution. So whenever you are calling the run method on the T1 thread, sir, do we call the run method? Better we call start method. Start method will call the run method. So whenever on that particular thread run method is called, then the thread will be moved to the running state. If a thread is in running state means it is under execution, right? So that is under processing. Once its execution is done, right, by calling the terminate method or dead method, it moves the thread into the terminate state, right? So a thread is in the terminate state means its execution is done, right? So that's what we moved that particular thread into the terminate state by calling the terminate method, right? So in new state, whenever we are creating a thread, what we will do, we allocate the memory, because to process what we need the memory, right? A thread is in the dead state or terminate state means once its execution is done means we will deallocate the memory which is allocated to this particular thread, right? This is the sequence or the flow of execution of the thread. So then what is this blocked state or non-runnable state? That is, beta, every threads, basically these threads contains the priority. The thread priority ranges from 1 to 10. 1 is the least priority, 10 is the maximum priority. So whatever the thread which contains the highest priority, that thread gets executed first, and lowest priority thread gets executed at last. For example, now let us assume, sir, I am created a T1 thread. So it requires, let's say 10 seconds of time to 10 seconds of execution time is required, right? Now you are started the T1 thread, right? That is in the running state. It is executed for 5 seconds. At same point of time, a new thread is arrived in the new state. T2 thread is arrived in the new state. Immediately, what the operating system will do, it will compare the priority of T1 and T2, right? So which is having highest priority? Let's say, sir, T1 is having highest priority, then it won't interrupt the execution. It will continue the execution of T1. Once T1 finishes its execution by finishing its time slot and its execution is done, then it moves the T1 into terminate state. It takes the T2 into the running state and it will start processing. It will start executing the T2 state. For example, sir, T1 having the priority as 3 and T2 having the priority as 6, right? So in this case, what the operating system will do? T1, it's under execution. It is already executed for 5 seconds. Immediately, whenever the high priority thread arrives in the new state, it suspends the currently executing thread or the low priority thread by calling the suspend method, and it moves the thread to the blocked state, right? And it takes the high priority thread from new state to runnable to running state. And once the high priority thread execution is done, then by calling the resume method, so what it will do, it resumes the suspended thread, right? Then the thread again comes to the ready state or runnable state, then runnable to running state. So we will pick the T1 from the waiting state or blocked state to ready state to runnable state, running state. So once already T1, it's finished its execution by 5 seconds, right? So it requires 5 more seconds. So the processor will allocate the remaining or rest of the 5 seconds. So once its execution is done, then it moves that thread to the terminate state. This is how the threads are going to be executed based on their priority, right? Sir, if the priorities are equal, then it checks about the arrival time. Sir, arrival time is also equal, then it checks about the processing time, which is having the which thread requires the less time, that thread gets executed. Sir, if all are equal, let's say arrival time is same, thread priority is same, and the time required to process the thread is also same, then that is called as burst time. So sir, in this case, what will happen? Beta, it will picks the thread in a random manner and it will execute the thread, right? This is how the threads are going to be executed in the thread life cycle, right? Now, this is called as the thread model, or you can say life cycle of the thread. Now, I'm moving beta. This is done. Sir, how to create the thread? Beta, you can create the thread in two different ways. Either by implementing the runnable interface or by extending the thread class, you can create the thread, right? These are only the two ways we can create the thread. Sir, now we will see one by one. Sir, how to create a thread by extending the thread class or by implementing the runnable interface. So here I'm taking an example beta. You can see here what I'm doing. I'm creating a thread by extending the thread class, right? Now, you should take your own class. This is the first step. Take your own class. The class should extend the thread class, right? Now, so within this thread class, what we will do, whatever the within this class which you are taken, within your own class, whatever the action which you want to perform, that you will write within the run method, because you are calling the start method. Start method will call the run method. Within the run method only, we are going to perform the action which you want to perform, right? That's what I'm doing. I'm taking the run method. Within the run method, sir, just I want to print 1 to 10. That's it. I'm writing the logic to print 1 to 10. Then I'm closing the run method. Then I'm closing the class. Next, what I'm doing, I'm taking one more class. Next, I'm taking the main method because program execution will start from main. Now I'm creating object for the thread class, right? That is your own class. So this class is extended the thread class, right? Now attach object of your own class to thread class, right? By creating object to the thread class, thread sum t equal to new thread. So you are attaching your own class object to the thread class so that this t acts as a thread for my thread class. Now you are calling t dot start. Then who is the t? T is the object of thread class. So that object is attached with my thread class object, right? In my thread class, do we have the run method? Yes, it goes to the my thread class run method and it will execute the logic which is there in the run method. This is how we will create a thread and we will start the thread right now. Sir, shall we execute this? Of course. 1 minute, beta. Yeah, guys, you can see here, I'm compiling my code, right? Then I'm running the code. I'm able to get 1 to 10, right? 0 to 9 means total 10. So this is a way of creating the thread and running the thread by using the thread class, by extending the thread class. And same thing you can also do by implementing the runnable interface. Now I will show you the example for that. Right. So here, what I'm going to do, I'm going to implement the thread class. I'm going to create the thread by implementing the runnable interface. Point one. I'm also going to cover one more topic, that is multi-threading by using multitasking, right? My intention here is I want to implement a booking system, right? Movie booking system or something like that, right? There, what I need to do, first I need to book the ticket, right? And I want to show the chair, right? For booking ticket, I'm going to use a thread, and to show the chair, I'm going to use another thread. So this is thread one, this is thread two. So I'm going to create two threads simultaneously, and I'm going to run two threads simultaneously. So executing one thread at a time, that is called as single threading. If you are executing more than one thread at a time, then that is called as multi-threading, right? This is the same program. Within the same program, I am creating the two threads to perform the task simultaneously. Now, here I'm creating a class name is theater. It is implementing the runnable interface, right? This is the second way of creating the thread. Now I'm taking string type of variable. Here I am taking the parameterized constructor. I'm initializing the instance variables of the class. Now within the run method, what I want to do, as we know, so here first I'm taking the, whenever the I value is 1, I'm displaying the string 1, whatever the string which you are passing. Let's say cut ticket. So cut ticket I value 1, cut ticket 1, I will take. Then I'm calling the sleep method, which is used to hold the thread for given number of milliseconds. 2000 milliseconds is almost is equals to the 2 seconds, right? I will hold the thread for the 2 seconds. If there is any exception in the try block, I will go to the catch block and I will handle the exception, right? So this is for the thread one. So thread one, whenever I am creating, so what I will do, I will pass a message that is cut ticket. So cut ticket one, thread one will cut the tickets. Simultaneously, I'm going to create thread 2, which is going to show the chair, right? Show chair, same 1, show chair 2, show chair 3. This is how it is going to execute. This loop is going to be executed for 10 times for each thread. Now, I will show you. So where we are doing that. Here, observe carefully. I'm taking the main method. Now, I'm creating object for the creator class, right? This is the obj, right? So which is holding a parameter that is cut ticket, right? Now I'm going to create one more object to the same theater class, that is object one, which is going to hold a parameter that is show chair. Now, as we know, whenever we are creating a thread, first create object to your own class, attach that object to the thread class, right? So now I'm attaching those objects to the thread class objects. I'm creating two objects through the thread class, thread sum t1 equal to new thread, right? So obj is attached, t2 and obj1 is attached. Now t1 and t2 are the two threads. T1 is holding obj, t2 is holding obj1. So obj is holding cut ticket, obj1 object 1 is holding show chair, right? Now I'm calling the two threads simultaneously. That in the sense you are going to execute these two threads parallelly, simultaneously. Now, whenever you are calling t1.stat, so it goes to start. You are calling the start method, means start method will call the run method. So if I value is 1, 1 less than or equal to 10, condition true. So string 1, what you passed? Cut ticket. Then At same point of time, again, immediately which thread you are calling? T2.stat. Then T2 start method also calls the same run method, right? I equal to 1 less than or equal to 10, true, show chair. That in the sense, cut ticket 1, show chair 1. Then you are holding for 2 seconds, cut ticket 2, show chair 2. Sometimes these may overlap because whenever there is a delay, then automatically T2 gets executed first, T1 gets executed next, right? This overlaps will occur depends upon the resources utilization. Let's say the processor is a bit slow, right? If the CPU is allocated to some other process, right? In this case, there may be a chance of overlapping, right? This is how we can execute more than one thread simultaneously by using this multi-threading mechanism, right? Now I will execute this. See the output. Again, compiled, and I'm running. So cut ticket 1, show chair 1, cut ticket, then show chair 2, cut ticket 2, cut ticket 3, show chair. That in the sense there will be an overlap while executing the threads, right? So that also you can avoid by using the join method.